For many of us, when we learn our first guitar chords, we're basically using the monkey see, monkey do method. So if I put my fingers like this, that's called a C chord. And don't get me wrong, this is actually a good way to learn a few chords, but in the long run, it becomes impractical to learn a large number of chords just based on their names and the shapes of where your fingers go. Today we're looking at chord qualities, their names, what all the numbers and symbols mean, and I want to get into the idea of functional harmony or chord functions, so what the chords actually do. And I'll try to prove that you likely already do have some ability to hear these chord functions. On piano, people usually learn the notes like C, D, E, F, G, and then that C, E, G is a C chord. But on guitar, because it's both so physically challenging as well as being rather hard to visualize, it is a really good idea to learn the shape of these chords and start practicing it for muscle memory. But the cool thing is that these shapes really can help us to understand music theory on the guitar, because there's the theory and then there's the shape, and they should align and logically reinforce each other. So first, we're going to learn how the main chord qualities are constructed, and we're going to visualize them in the easiest possible way on guitar. We'll start with the archetypal day one piano chord of C major, C, E, G. On the keyboard, it's easy to see that we're taking the first, third, and fifth scale degrees, but guitar can seem a little more confusing. I'm sure you've had the experience that one source will say that this is a C chord, and another says that C is like this or this. But technically, as long as we have the notes C, E, and G, then we have a C major chord. The notes can be close together or far apart, or be in any order, or have any number of doubled notes. But as long as it's all C's and E's and G's, then we can analyze it as a C chord. So the name alone doesn't tell us everything about the sound. Looking at the intervals, we find a major third between the root and third, a perfect fifth between the root and the fifth, and then a minor third between the third and the fifth. Let's look at single string major triad arpeggios to most easily visualize the intervals on guitar. If we make the open string the root of the triad, we need a major third and then a perfect fifth above the open. So we got the open, 4th fret, and 7th fret, and those are the chord tones. In a major scale, each degree gets its own letter name, which means that if we start on D, all we need to do is count the 5 letters. Doesn't matter sharp or flat yet. D, E, F, G, A. And then we can see we need to use the letters D, F, and A, which means we'll name this note F sharp. And this intervallic relationship is true for all major chords. And one really cool thing about the guitar is because of all these shapes, we can sort of reverse engineer them to answer theory questions. Say we wanted to play or spell an E flat major triad. We'd take the major triad shape and see that the root is this lowest note. So if we move the shape to the fret where this note is E flat, then we will automatically get the right sounding chord. So we count up C, D, and then the black key before E is E flat. Then if we wanted to spell it, we can visualize and determine what the notes are. If you're not super confident with the note names and locations, later on I'll recommend a video that would be a good place to start. So we started on E flat, and we know the letter names have to be E, G, and B. And so we have E flat, G, and then this black key note will have to take the name B flat. Let's move on to minor triads. It's the third of a chord that determines its quality. A major chord has a major third, and a minor chord has a minor third, and they both have the same kind of perfect fifths. Major means big, and minor means small. To easily visualize the pattern of steps in a minor triad, let's look at the arpeggio on single strings again. We can make a G minor triad on the 3rd string. The open is the root, we go up a minor 3rd, and then a perfect 5th above the open. So we get open, 3rd, and 7th, and those are the chord tones. There's a minor 3rd between the root and the 3rd, and then there's a major 3rd between the 3rd and the 5th. And we count up the 5 letters G, A, B, C, D, and we see that we need to use the letters G, B, and D, and so in this case we'll spell it with a B flat. And then it's the same deal with the spacing or doublings not affecting the name. Major and minor are by far the most commonly used chords, but we also have diminished triads, which have a minor third, but instead of a perfect fifth, they have what we can call a diminished fifth or a flat five. And so it's made of two minor third intervals. And then we can also have augmented triads, which are two major third intervals, which gives us an augmented or sharp fifth interval between the root and the fifth. It's a little oversimplified, but basically yes, major triads sound a little brighter or happier, and minor a little darker or sad, I guess. But we rarely hear just a lone triad, and so it's really their context, or what we might call their function, that determines how they sound. We'll get into that soon, but first, let's talk about chord names and symbols. If you play guitar, you've probably seen lots of chords notated this way, what we might call lead sheet symbols. Let's see how they work. When we see a chord name like this, with just a letter name, we assume it's a major chord. So these are all major chords. And for minor chords, we actually need to indicate somehow that it's minor. Usually we see just the lowercase letter M, uppercase tends to mean major, or sometimes a minus sign. For diminished, we usually either use this little circle or else we'll write dim. And the other quality of triad we might see is augmented. It's usually written like a plus sign, or else the abbreviation augmented. It can also be written like sharp 5 or augmented 5. Now for the numbers, they're essentially telling us the size of an interval, and then we count up that many letters, and for example, add that note into the chord. So if we have this chord C major 7, we have a C triad, and then we count up from the root a major 7th from C. So C is 1, and we go up the scale until we get to the 7th, or B, and then we add that into the chord. A minor 7th chord is a minor triad with an added minor 7th. For major 7 and for minor 7, we actually need to indicate that the quality is major or minor. And there are some fun variations for major 7 that I like. But what if it just says 7 and doesn't indicate major or minor? The sort of default 7th chord is a dominant 7th chord. And so we don't even need to say dominant 7. We can just say something 7 and we know it's a major triad with a minor 7th added. We'll see where dominant chords come from in a moment when we talk about chord function. If we see a 9, that means to add another note to the 7th chord. So C major 9 is the C major triad plus the 7th B and then the 9th D. Or C minor 9 is the same idea, extended up to the 9th. And then just C9 means it's a dominant quality because that's the default quality. And so we'll add a 9th to a C dominant 7th chord. Sometimes we see to add something, like C add 9, and in that case we don't follow the pattern of thirds extensions, but we just add it to the triad. We don't need to say add 6 because we assume that we just add it to the triad. So we have the major triad, and then we have the chord extensions, 7s, 9s, 11s, and 13s, following that same pattern of thirds. And so technically, if it says 9, that means it also has a 7th. If it says 11, it should have both a 7 and a 9. And a 13th chord is funny because if you rearrange the notes, you actually have the entire scale. But spread out like this tends to sound much better than all close together. And triads already have roots, thirds, and fifths, so it would be redundant to see something like C10 or C12 or a C14 chord, because we would just assume those notes are the root and third and fifth. And we can also shift the order of the chord extensions around without affecting the name. I should point out that we only have so many strings and notes that we can reach, and so for extended chords on guitar, we often omit notes and use incomplete chords. For example, we often leave out fifths for major, minor, or dominant chords, and we don't really miss it that much because it's sort of the most plain note that's the same in all three chords. We can also even leave out the root if it's in a situation where someone else is providing the bass notes. So we can leave notes out of chords either because of necessity, or to make it easier, or just to taste. As a guitarist, I would be remiss not to mention power chords. When I was younger, I basically just knew that something 5 meant to play that power chord. But now you can probably see that the 5 is because we count up to the 5th of the chord. But it's the same perfect 5th as both a major and a minor triad would have anyway. So the thing about a power chord is that it doesn't have a third, and so it has its own sort of hollow or empty quality. By itself, it's not really major or minor. Sus means suspended. Historically, the suspended tone would be prepared by the previous chord, and then when the next note in that voice should move to the next chord tone to a step lower, the previous note is instead held over into the next chord before then resolving. The most common suspension is the 4-3 suspension in chords. And so with lead sheet cymbals, if we see a sus chord, we'll assume that the chord has a perfect fourth instead of the third. Or it's sort of the same idea with the sus2. We play the second instead of the third. Perhaps the simplest way to think of inversions is with these close position triads. And it just means that you can move the lowest note up an octave or the highest note down, so that you get a different lowest note. On piano, this is easier to visualize because you literally just move the one note, but on guitar, the equivalent voicing either has to go to the next set of strings, or even more confusingly, move up the same set. And just like the arrangement or how many of each note doesn't change the chord, the inversion only indicates what the lowest note of the chord is. And so we have 3 possible lowest notes. And we can say that the C on the bottom is root position. And if the third is on the bottom, then it's first inversion, and the 5th on the bottom is second inversion. 7th chords have 1 more note that can be the lowest, so they have 1 more possible inversion. And this would be a logical time to mention slash chords, but sadly not this kind of slash chords. So with these symbols, the left letter is the chord, and then the right letter is the bass note, or the lowest note of the chord. So we say C over E, and it means a C triad with E as the lowest note, or a first inversion C triad. There can also be other slash chords that aren't just inversions of triads or extended chords. So we can get all these cool chord possibilities, like for example, this F over G, which is basically used as a dominant function suspended chord. Now, what does it mean when we say that a chord has dominant function? Well, let's talk a bit about functional harmony, and then we'll look at functional chord symbols. Let's see if I can convince you that you already can hear some chord functions. Here's a familiar little tune, and I'm going to use a little musical syntax and grammar to express something. And so if it sounded a little silly and you either laughed or groaned, that proves that you are familiar enough with the syntax and grammar of music to be in on the joke. And with theory, we can try to further classify and describe what we heard, which was sort of a hilarious musical dad joke, because this first one sort of makes it sound like we're going to hear one more time. And then when we do hear it one more time, instead of the right chord, we hear an even worse wrong chord. And it also functions kind of as a sad chord, which is a little ridiculous for Twinkle Twinkle. And then finally, on the last time, we do a sort of ostentatious right note in the wrong chord ending. And so we've just been denying over and over the sort of proper resolution. Lead sheet symbols tell us everything we need to know to create the right chords, but they don't tell us anything about the function of the chords, which is what the chords do. We could just write C, and then that alone doesn't tell us the function. So here are some functions that a C chord might end up fulfilling. Roman numerals to indicate the function, and so in every key, the lead sheet chord would be different for the tonic, but the function is always 1 or tonic. We use a capitalized Roman numeral 1 for the tonic of a major key because it's a major triad. But if we really want to hear the function of the tonic chord, we can tonicize, or what we might call confirm it, by hearing the dominant chord and then the tonic. In this key, it will be G and then C, and in any key, it would be 5-1. And then we can make the tonic-dominant relationship even more clear by adding a 7th to the dominant chord. This increases the dissonance of the 5 chord, which enhances the sense of resolution to the tonic. Even if we just hear the bass notes C and G, we tend to hear the C as the stable note. Like if you ended on G, it would sort of leave you hanging. And so the G chord is what we call the dominant chord, and it has dominant function, which is basically a way of saying that it tends to have that drive to resolve back to the tonic chord. And tonic function is the one that sounds more stable or has a kind of finality to it, or like you would stereotypically end on it. And then there's another chord function which we call subdominant, or Roman numeral 4. And a subdominant triad built on scale degree 4 sounds sort of midway between the tonic and dominant, in the sense that it sounds like you're away from the tonic, but it's not as tense as dominant, and it doesn't have the same perceived drive to resolve back to the tonic. The reason I like these chord functions so much is that it's ultimately easier to understand, hear, and remember music when you think of theory like this, and then you can apply it to any key. For example, if we remember the chord functions for a song, then we can just apply it or compare to any key, which is better than trying to memorize it this way. It sort of conveys the essence of the harmony. We previously talked about how A natural minor is related to C major because they are both modes of the pitch collection of natural notes, or white keys. So C major is C, D, E, F, G, A, B, C, and the functional name of each note is tonic, supertonic, mediant, subdominant, dominant, submediant, and leading tone. A minor is A, B, C, D, E, F, G, A, and we get mostly the same, but for scale degree 7, we have the subtonic, which is like below the tonic. So that means this note isn't functioning as a leading tone, because leading tones are a semitone below a tonic. And the tonic-dominant duality is so fundamental to tonal music that even in minor keys, we essentially just move the subtonic up to make it into a leading tone. This way we get a proper dominant function 5 chord. And this is essentially why we have the different forms of minor scale. The harmonic minor scale can be seen as all the notes in the main chords in the key, 1, 4, and 5. But then when we play a harmonic scale, the one big step, which is an augmented second, often sounds a little out of place in a melody, and it can be hard to sing that interval. And so many times musicians also raise scale degree 6 in order to smooth it out a little more. And that's where the melodic minor scale kind of comes into existence. And usually composers sort of shift between the different forms of the scale depending on the harmony of the moment. We'll get more into the exact triads and seventh chords later. In the meantime, it would really help if you're all brushed up on your note names and locations, so make sure to watch this next.